Hello, everyone. Yeah, here we go. Welcome to our talk about Know Your Repository, Navigating Growth with Git-Metrics. I'm Steffen Hiller. I'm a staff DevOps architect at GitHub, working in our customer success team for 7 years now. Fun fact, the last time I was here was 7 years ago, doing my onboarding, and the Wi-Fi is still working. So it's true.
My name is Zoran, and I'm a freelancer. I work as a freelancer, mainly on full-stack projects and cross-platform projects. And Steffen invited me to take part to the project as a co-contributor last year. And before, I only used Git as a normal user, so I'm not really experienced in the more deeper material of Git. But with the project, I could learn a lot until now. And I'm happy to be here and hope you enjoy the talk.
So just a quick overview of what we will talk about. We will show you what is Git-Metrics, then why we build it, and then we have a short demo, and then we go through examples where we go a little bit deeper into what it shows. Git-Metrics is an open source command line tool written in Go. It provides repository size growth metrics, including future size estimations, content composition insights, as well as contextual activity data. So at GitHub, I work with many enterprise customers. And each enterprise customer has at least one repository that is that monorepo, meaning everybody in the customer's company talks about it and knows this is their large repo. It can be also many other large repositories that customers have, obviously. And I encounter these when we help customers with migrations, for example, from server to cloud. Then sometimes they also have performance or availability issues, either mostly I personally see it when they host it themselves on their server. And then also there's often companies consolidate repos into a single repo, multiple monorepos in another bigger monorepo. And when we help customers with that, the first thing we look at is the repository size. There are amazing tools already out there that we use almost daily. Two are Git Sizer from Michael Hegarty and Git Filter repo from Alicia, who is also here and talking later. And so with Git-Metrics, we wanted to explore if we can contextualize the information that these tools provide further to increase a bit the size awareness of Git repositories. So we wanted to see if we can answer questions about how much it has been growing in the past over time and give a better sense of if, let's say, customers will continue to use it in the way they do, where it will be and how it will grow in the future. Give more insights into what is actually in the repository, and then also provide more activity-related metrics that help explain trends in the repository. It is purely like a client-side tool. It does not access server-related metrics such as fetch and push requests, for example. That is also often important when looking at the whole picture. But it can help to contextualize and explain the server metrics that you see. One thing that you probably have heard of, AI. So that is also a thing that comes up more and more also with customers where they are aware of that the use of AI will also continue to make their repositories grow even faster with AI-generated code. And in full transparency, building this tool this year, we explored ourselves a little bit of how far you can take AI and with building software. So we heavily made use of AI as well. That's why we have this T-shirt on, I guess. So let me give you a quick rundown, like just running it for a few seconds, so you get a sense of what it is and how it runs, and then we go deeper into explaining the output. So here, in honor of Git's 20th birthday, and we had Git merge, I run the tool in the Git repository. It's a local clone. So you probably know if you have a binary that starts with Git in your path, you can just run the binary through Git and omit the dash in this case. So just Git space metrics. So I'm going to just hit enter here. So it will, Zoran will provide you, explain a little bit more the output. It is, we try to make it a little bit interactive so that if it's for larger repositories, you see as soon as possible something while it runs. And so this is right now all the output we provide. There are some other sections we're thinking about, but this is what we have now. And Zoran will talk more about the first sections.
Yeah. So first of all, I want to introduce you to our little presentation tool. We choose to create our own little helper to provide the sections of the output on the left side. So the output of Git-Metrics is separated into multiple sections, mostly logical sections. And we highlight each section where we are at. On the right side, we provide some additional information about it. And on the bottom right, you can see the Git commands that we are using in each section. On the top right, you can see the examples that we are going through. So in this case, we are at Git, but we have also Linux and Chromium as an example that we want to compare with each other. So in general, we try to focus on human-readable and user-first output. So our output is mostly try to be aligned in a certain width and with a certain readable design in mind. The first two sections are about giving a general data information about the output to give it a certain context. And as we can see, we start with the start time. This is also because we track the runtime in the background. And this is helpful also in combination with the machine info, because if the runtime is too long, it might be the machine that is the bottleneck here or the system. So we just want to be sure that if it runs too long, we have some inside information about the system. With these repositories, we are using the most recent fetch date. We need a date basically to orientate our whole calculation against. So for the current state of the repository, we are using the most recent fetch here. Sometimes there is no fetch because it's a local repository. You never added an origin, or pulled something, pushed something. So in that case, we have a fallback, but here we use the most recent fetch now. In the bottom, you can see the age of the repository, and as we have Git as an example, we can actually see that it turned 20 years this year. And in honor to the repository and its 20th anniversary, we are starting with it with our first main section. As mentioned before, Git-Metrics is supposed to focus on the size and the growth of the repository. So with this section, we try to give a high-level overview of the progress. This is the pattern that will be repeated in the frequent sections also. We show always the past, the current state, and in this particular case also the estimation. What we can see are commits, object size, and on-disk size. We mostly focus on the on-disk size because we think it's the main impact for the actual traffic and size on the disk, as it says. And in these three categories, we also have supporting columns, which with delta, percentage, and also we have a concern column. The delta should just show the change in that year. The percentage should show the percentage of the delta related to the total state. So in this case, like 2005, we have 4% of 8,100 commits in the commit section. The concerning column should be a little indicator. We wanted to provide a level of concern. So especially when you take a look at the estimation of the repository, that you could indicate, okay, there is some concern coming up in the future. The estimation, we had several approaches how to do it. In the end, we chose now to use the delta of the current year and to extrapolate it to the full year. So in case of, let's say, on the disks, the on-disk size, we have a current delta of 22 megabytes, and we estimated for that year, at the end of the year, to 2025, it will be about 29.9 megabytes. This rate we apply to also all the future years, and with this approach we are happy. With the previous ones we were not, but yeah. So let's take a look maybe a little bit at the data. With Git we have a pretty exemplary repository. The activity on the commit side is pretty stable since the past 20 years. The disk size is changing. It's increasing, especially in the past 4 years. But with a repository in this category size, we still don't face any concerns with that. As next, we will take a look at the Linux repository, which has a much higher activity. The commits are much higher. The on-disk size is higher, just in nature because of its project. And still, we are focusing more on the full circles, and here we still, even though it has a decent size, it's still healthy and not concerning for us. So we tried to figure out what could we show for a concerning repository, and there we searched for some open source, for some open source, repositories, and we found Chromium. So we tried to clone Chromium, and we failed multiple times. Usually, as a developer, you don't clone the full repository, but as developers, we tried it, and it failed until we had a stable connection for a few hours, and then it was on our machines. So how did that happen is the question, and I mean, we can look at the past. So there are certain thresholds. We say that for the on-disk size, the 20 gigabyte is a alarming threshold where it's turning to be concerning state. This happened here in, I think, 2020. And if we look at the end of this year, it will probably have the triple of the size of an already concerning state 4 years ago. And if we also look at the prediction on 2030, it will be above 100 gigabyte. And the problem here is that hardware is improving, also Git is improving, the performance of Git is improving with every update, and we cannot really say what is a real concern, but it helps you to get a direction and in a certain awareness.
Yeah. So one question here obviously is, okay, what is contributing to this size increase here? And for that we have another section, which is where we look at the file extensions of the files that are in the repository. Interestingly, there's one extension in the top. So the first table is just a snapshot of the current state, and we see that more than 50% of the on-disk size is actually coming from one XTB extension. We will see a little bit later where we see what it is, and I know time is rough, so I will go fast. The last column is the compression ratio, though that gives also some indications on what type of files that these are. So PNG in the third row, for example, shows there's almost no compression happening since it's PNG. On top of the current snapshot, we wanted to provide a little bit in the earlier table how the evolution of the repository was, and it seems like these XTB files It was more lately like where they turned out to be like the #1 extension as contributors to the increase of the size. And now is currently in this year, last year, they seem to be contribute like 3/4 of the increase of this size. So we have another section. So on the like Zoran said, we show the Git comments here. So this is actually derived from the same Git ref list command that we used in the table before. And then we have, okay, it's a little bit cut off here, but this is just like also giving you a sense of like what is in a repository. So monorepos often can have also multiple projects, and here you can get a little bit more sense of like, okay, do we have specific projects in your monorepo that take up the large chunk of the repository. Here you can see translation resources is on the top, and that's also where the XLB files are, XTP, sorry. And it seems like they are like translation related. Just going quickly up, just as a nice contrast, when you go like to the Linux repository, that's kind of an ideal kind of state where you see it's mostly code files, right? C and header files. In the Git repo, it is a little bit mixed. There are the PO files, which are also translation files, like in the Chromium repository. But overall, the Git repository is like not that big and therefore concerning. Just last. So we also are experimenting with adding some activity-related and data for additional context. So it's not directly like on size. And so here, like how many authors are actually committing to that repo on a yearly basis. Then like what are like the bursts of like how many commits you have like per day on peak, an hour, and a minute. And lastly, we also want to show some contributors stats, and mostly when we go like to Chromium, for example, to also identify if there are any automations that like workflow changes, like especially like in mind with like at customers, enterprise repositories that potentially contributed to like the change of like evolution in the past years. So that's what we want to show with these last two tables about authors and committers. I think we had time, so so that's our last slide. You may have heard the quote of, or saying, repositories never get smaller. It was likely not Albert Einstein, but just
likely
fun. And a note also, right? It is not just for large repositories. It is like for you to know your repository. In fact, when we tested it also against our Git-Metrics repository, we found that at some point we put in accidentally a test Git-Metrics binary that was not meant to be there. So it is, I think, helpful for small and large repositories. And that's it. That's it.
Thank you.